Welcome to Fun with Physics. On this segment, Newton's Snifty Nuggets, we'll be talking about Newton's 3 laws of fun. Just kidding. Motion. Laws of motion. Here now and ready to make my acquaintance is your wonderful co-host, Allison Pope.
Thanks, Sam, for that stupendous intro.
You're welcome.
As usual, now let's get right into the good stuff. And before we even think about talking law, we need to know who this handsome devil Newton really is. Here to tell us a little bit more about Newton is our local expert, Alex Merritt. She is joining us all the way from, well, just across town. Alex, thanks for joining us today to teach us a little bit about who Newton is and his laws.
Thanks for having me. I'm so excited to be able to inform you about just one of my many heroes. And on that note, let's get started. Newton was born in 1643 in England. He was a mathematician, astronomer, and physicist who owned more history books than he did science books. He was known for having a bad anger issue and suffered 2 mental breakdowns. He came up with what we know now as Newton's 3 laws of motion, and this is what I'm going to tell you about now.
Newton's first law of motion, also known as the law of inertia, states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. In these examples, here you see the gorgeous people in the video, how their bodies want to keep on going in a straight line when the car comes to a stop. And thank God for seatbelts, because that's what keeps your body from continuous movement forward and going through the window shield. In our first example, you saw that a ball wanted to keep on going, but was stopped by friction and a wall. The bike example is one of those special gems that qualifies for all 3 of Newton's laws. In the first law, if you keep on pedaling the bike after you're going, you'll keep on going. In the second law, the harder you pedal, the faster you go. In the third law, the wheels are acting as a reaction-action pair. Newton's second law of motion states that acceleration is produced when a force acts on mass. The greater the mass, the greater amount of force needed, or force equals mass times acceleration. Put in simple terms, it's easier for one person to be pushed by 2 people than by 1.
So far, we've heard about Newton's 2 laws of motions, but join us after the break to hear about Newton's 3rd law.
I'm a wild deer, and I'm out here eating leaves and whatnot. When I come across this road, and I'm like, huh? What is this thing? That's when you come around the bend, and I freeze in your headlights.
'Cause that's what we do. If you have cut rate insurance, you may be up a Greek thousands. But if you remember that Newton's 3rd law states, for every action there is an equal and opposite reaction, you might want to stay slow on the back roads. That way you can save a few bucks, and some doughs. My spleen.
Formally stated, Newton's 3rd law is, for every action there is an equal and opposite reaction. This gentleman throwing the ball is the action. The ball bouncing back and hitting him in the face is the reaction. How funny. As the gas is released from the balloon, it pushes against the outside air, and the outside air pushes back. What a beautiful sight!
Well, that looks like it's all the time we have for today, guys. Thanks for joining us on Newton's Nifty Nuggets, a very, very special edition of Fun with Physics.
Alex, thanks for joining us today. And remember, knowledge is power.
I'm just a dreamer, trying to find my way.
looks like it's all the time we have for today, guys. Thanks for joining us on Newton's Nifty Nuggets, a very, very special edition of Fun with Physics.
Alex, thanks for coming in. And remember, I'd like to introduce my wonderful guest star, Alex Merritt.
Thank you. Wait, I'm confused.
I can't
Wait, okay, hold on.